Okay, shh. Now you'll notice that when we took the square root of 9, we got a whole number. What is that called? A perfect square. Good. When you do the square root of 20, is it a perfect square? No. So you're going to have to factor tree it. Now, I don't know when you learned this in 9th grade if your teacher showed you a little story behind this to help you remember it, but this is how the story goes. Well, first you have to factor tree before we can start the story. What numbers multiply to give you 20? Shh. Guys, please close your mouth unless you're talking to me. 4 and 5, or 10 and 2 would have worked. It doesn't matter which two numbers you start with as long as they multiply to give you a 20. Now, what two numbers multiply to give you a 4? 2 and 2. 5 is prime, so you cannot factor it down anymore. You just bring it down to the bottom with the other ones. And see how we've created a tree? Well, right, let's talk about the story. This is how you remember how to do it. Once you're done with your factor tree, you circle any pairs that you have. So see how we have a pair of 2's? You circle them. Those 2's are sitting on a couch. The dad comes home and finds out that his daughter has invited her boyfriend over, and they're sitting on the couch holding hands. That is not allowed in this house, so he gets really mad and he kicks the daughter out of the house and he kills her boyfriend. Okay? You will. Now, the older brother was just in his room playing video games, so he was being good, so he gets to stay inside. And that's the answer. Yes, the radical is the house.
You're harmful.
Harmful. Okay, now let me show you a method to check your answer. If you take the outside number and multiply it by itself, guys, you've got to close your mouth. No. What is 2 multiplied by itself? And what's 4 times 5? 20. What's 3 multiplied by itself? And there's no inside number to then multiply by, so 9. That's the way you check to make sure you have the right answer. Now let's try 48. This factor tree I already know ahead of time is going to be a little larger, so I'm just going to make myself a little scratch paper right there. You'll just have to squeeze yours in. Okay, what numbers multiply to give you a 48? Okay, 6 and 8 would work. There could have been other options like 12 and 4, but 6 and 8 will work. What numbers multiply to give you 6? Okay, what numbers multiply to give you 8? And then 4 can be broken down one more time into another set of 2's. Right. You multiply them. Okay, so this time, look, we got twin daughters at home, and both of them have invited their boyfriends over, and they're holding hands, which is not allowed. Okay? So, the dad walks in, kicks both daughters out of the house, meaning that you have a 2 and a 2 outside the house. You multiply them, which makes 4. Both of the boyfriends get killed, and then this little brother 3 was being good, playing with his toys, so he gets to stay in the house.
Violence.
Okay. Okay, so now that we've reviewed simplifying radicals, we're going to talk about complex numbers. So can I erase this?
Yeah. That's what she's going to do.
Okay. Complex or imaginary numbers occur when you take the square root of a negative number. We use I to represent an imaginary number, and the definition for I is I equals the square root of negative 1. This is the most important thing that you're going to need to memorize. I equals the square root of negative 1. Okay, now that we have I, we can simplify expressions that have negative numbers under the square roots. Tell me why the square root of negative 9 doesn't just simply equal negative 3. Right, because remember up here, the whole reason the square root of 9 is 3 is because 3 times itself is 9. Well, when you do negative 3 times negative 3, do you get a negative 9? No, you get a positive 9. That's why you can't take the square root of a negative number. Okay, because when you take that number and square it, it doesn't bring you back to that original number. Couldn't you basically look at the square root of negative 9 as the square root of a positive 9 times the square root of a negative 1? Couldn't you basically break that apart as a positive 9 and a negative 1? Well, what did we just learn the square root of 9 is? And what did we just learn the square root of negative 1 equals? I. So that's your answer, 3I. Because you can't take the square root of a negative number, so you have a complex number, an imaginary number, and you represent it with the letter I. Okay, so we already did the square root of 20, or 20 up top. What was the answer for the square root of 20?
2 negative 5I.
2 square roots of 5, right? So since it's negative, you'll just write 2I square roots of 5, and that's the answer. Okay, so what would the answer for the square root of negative 48 be? 4I square roots of 3. Okay, pretty easy, right? You just have to remember to put the I when it's negative because it's a complex number. Okay, now, you're really going to have to focus here and pay attention, okay? It might still go over your head, but I'll try to explain it a couple of times. But if you just give it a chance and pay attention, most of you will get it. Okay, so what happens when you multiply I times I? Don't you get I squared? Kind of like x times x is x squared, so I times I is I squared. Well, didn't we already learn up top that I equals the square root of negative 1? So if you have I times I, which is I squared, wouldn't that just mean you put a squared on that square root of negative 1? Okay, do you remember, hold on, let me get to another page. That's for freshman math. Do you remember if you had a problem like the square root of x equals 5, how you would isolate this x and solve for it? Okay, what is the inverse operation of this? How would you solve that one for x? Correct. You would subtract 5 on both sides. That's called inverse operations. What is the inverse operation of like that? Divide by 5. Okay, those are called inverse operations because they undo each other. They cancel each other out. To cancel out a square root, you square it, and it cancels out, leaving x by itself. But then since we squared this side to cancel it out, you square that side, and you get 25. Which makes sense, doesn't it? Wouldn't the square root of 25 have been 5? So, now let's go back to this. If you know that I equals the square root of negative 1, I squared would be the square root of negative 1 squared, right? Well, won't that 2 cancel out that radical, leaving just negative 1? So that means I squared equals negative 1. Let me say it again. Does everybody understand that I equals this? So that means if you take the I and square it, you would just take this and square it, right? Well, once you do that, it cancels out the house because those are inverse operations, leaving just I squared equals negative 1. That's another important thing that you need to remember. I squared equals negative 1. Really, that's probably the most important. I squared equals negative 1. So, let's talk about what would happen if you have I times I times I. That would give you I cubed. Well, think about it. If you have I times I times I, that's I cubed, but couldn't we break it down into these two, making I squared? Well, what do you know about I squared? What did we just learn I squared equals? And then that negative 1 is left over with that I that we haven't done anything with yet. And what's negative 1 times I? Just negative I, right? That's why I cubed equals negative I. Okay, so now let's look at the next page. If you have I to the 4th, isn't I to the 4th basically I times I times I times I? Okay, well, doesn't every two i's make an I squared? And what do you know about I squareds? They're negative 1. So what's a negative 1 times a negative 1? That's why I to the 4th equals a positive 1. Okay, so let's talk about I to the 5th. If we had added in a 5th I right here, these two would have made a negative 1. These two would have made a negative 1, which combined makes a positive 1. But then don't you have an I left over? So I to the 5th equals what? Okay, let's look at it again. Okay, say I to the 5th would be I times I times I times I times I, right? Well, every set of i's is an I squared. And what do we know about I squareds? They equal negative 1s. So these 4 i's have made a negative 1 times a negative 1, which is a positive 1, right? But we haven't done anything with that one yet, so we bring it down. Well, is the 1 really necessary to write? So that's why I to the fifth just equals I. Now, obviously, when you have them this small, like I to the fifth or under, or even like anything under 10, you could write it out and pair them up and figure it out. But what about when we get to larger ones, like I to the 21st? Do you really want to be writing out 21 I's and pairing up every set? No. So there's a method, a shortcut method. You divide it by 4 every time. So what's 21 divided by 4? 21 divided by 4.
5.25.
That's just the shortcut method. It's correct. You'll notice over here in this little shortcut box, it lets you know that when you do your power divided by 4, if you end up with a 0.25, it's going to be I, right? So I to the 21st equals I. Look, these are your only 4 options. Pay attention. These are your only 4 options. You're going to end up with an I, a negative 1, a negative I, or a positive 1. That's the only thing you can end up with in any of these. Well, yeah, we're going to do all these for each one. So if you have I to the 22nd power, you take the 22 and divide it by 4, and what do you get? Okay, the shortcut method says that if you end up with a 0.5, your answer is negative 1. So I to the 22nd equals negative 1. Now let's talk about why. We're not going to write out 22 I's, but try to visualize that you have 22 I's. Every set of I's, every 2 I's makes a what? A negative 1. It's a pair, which is I squared, which is negative 1. How many pairs are you going to have with 22 I's? 11. If you have 11 negative 1s, ain't your answer going to come back negative? Think about it. If you have an odd amount of negatives, don't you end back up with a negative? So that's why you get a negative 1. So like for this one, wouldn't the first 20 of them have made 10 pairs of negative 1s, which would have come back as a positive 1? But then you would have had that 21st I left over, so it would have been positive 1I, which you just write as I. Okay, so let's think about this one before we do the shortcut method. If you have 23 I's listed out, how many pairs of I's could you have? 11. The first 22 I's will make 11 pairs. Well, 11 negative 1s is going to be negative 1, right? And then you have the 23rd I left over, so negative 1I. Now, if you can't remember how to do it like this, divide it by 4. What's 23 divided by 4? Okay, and anytime you have a 0.75 left over, your answer is negative I. Okay, think about I to the 24. That's 24 I's. And every set of 2 makes an I squared, which is equal to a negative 1, right? And how many pairs would 24 I's be? 12. Remember, if you have 24, you could do 12 pairs of I's, right? And each of those makes a negative 1. Well, if you have 12 negative 1s, isn't that an even number of negatives, which will come back positive? And that's why you get a positive 1. And anytime when you divide by 4, if you get a whole number, it's automatically 1. Okay? Does it kind of make sense? I know you don't have it memorized yet, but does it make sense how they're getting these answers? Okay, now let's go to the next page. This will be easy. This is going back to what we did a second ago. What is the square root of negative 16? 4i. Now let's talk about why. Okay, look over here and I'll show you an explanation of why. Think about it. The square root of positive 16 equals 4 because 4 times 4 is 16, right? So if the square root of negative 16 equals 4i, it must be because 4i times 4i equals negative 16. Well, let's see if it does. The 4 times the 4 makes the 16. What's I times I make? I squared, which is equal to negative 1. So, okay, let me say that again. If square root of 16 equals 4, it's because 4 times 4 is 16. So the square root of negative 16 equals 4i because 4i times 4i is negative 16. And the way they get that is 4 times 4 is 16. I times I is I squared. We know that I squared equals a negative 1, so this negative 1 times 16 makes it negative. Does that make sense? Okay, number 3, what's the answer? 9i. Okay, number 5 is not as easy because we're not dealing with a what? A perfect square. So what do we have to do? The factor tree. Yes, you could call it a family tree, I guess. Okay, so 63 breaks down into what two numbers first?
7 and 9.
Okay, 7's prime, so let's deal with 9. What does 9 break down into? Okay, and then 7 just comes down. So do we have any pairs to circle?
Yeah, 3 and 3.
Yes, so remember, this one gets kicked out. This one gets killed, so it's completely gone, and the older brother 7 was being good. But since it was negative, you have to throw that I outside too. Wait a few more minutes. Okay, number 7, is that a perfect square? No, so we have to yeah, that's the answer. Just think about it. Look, what's 3i times 3i? Negative 9. Remember, look, 3i times 3i is 9i squared. We know I squared is a negative 1, which would make it a negative 9, and a negative 9 times 7 is negative 63. I teach it every day. I mean, okay, so for number 7, is it a perfect square?
No.
No, so we have to factor tree it. 4 and 8. 4 is a 2 and a 2. 8 is a 4 and a 2. Can we keep going? Right, so this 2 and 2 come down. This 4 becomes another set of 2's, and then that 2 comes down. So how many sets of 2's do we have?
2, so it'd be 4i to the...
Right, since there's 2 of them, that means the boyfriends both get killed, and these girls both get kicked out, and you multiply whatever's kicked out together, which makes 4. It's negative, so you put the I, but the 2 was being good, so he stays inside. Okay, 9's easier, because it's a perfect square. What's the square root of negative 100? 10i. Okay, number 11, D'Orlando, what'd you get for 11? Very good. Number 13, what do we have to do? Factor tree it. Okay, what are some factors of 75? 25 and 3 would work. Okay, 25 breaks down into 5 and 5. And so look, we've got a set of 5's. Circle, kill 1, kick 1 out. It's negative, so you put an I, and then 3. And just remember, you can still do your little method. 5 times itself is 25. 25 times 3 is 75. Okay, and then number 15, what's the square root of negative 144? 12i. Okay, I want you to be working on the evens by yourself.